All right, guys, so we're going to be starting our unit on electrostatics. This is the study of static electricity. Static electricity is not current electricity. These are charges that are not moving and they build up on objects. So you could imagine like touching a metal doorknob as you walk across a carpet and you get a shock as you touch the doorknob. That is a bunch of electrons that have built up on you, and when you go to reach out for the doorknob, you discharge those electrons and then you feel that shock. So we're not yet at current electricity. That's next unit. And before we get there, we actually have to understand what charges are and things like that. So we're going to basically start today thinking about charges and also talking about the electroscope. And hopefully when we're back at school, maybe we can do a little activity with the electroscope. So static charges. A lot of these things you may know from classes you've taken in the past. Hopefully they ring a bell. So first thing we're looking at positive charges. Well, a proton has a positive charge, and an electron has a negative charge. Okay, in a neutral atom, we have the same number of positive and negative charges. Okay, this idea of positive charge, negative charge, and also neutral is going to come into play in this unit. Okay, one thing you always want to keep in mind is where are the protons located? The protons are located inside the nucleus of the atom, and the electrons are on the outside in those outside shells of the atom. So when we get to the electroscope and charging of objects, we have to recall where these subatomic particles are actually located. All right, so you should always remember, and you probably know this just from general information, that like charges, like a positive next to a positive or a negative next to a negative, those are like charges. They will always repel. And opposite charges, like a positive and a negative, they're going to attract. This law of electrostatic charge, this is what's going to determine a lot of the forces and things we're going to be talking about. So we're always going to go back to what do like charges do, what do opposite charges do. Okay. All right, so now we're going to start talking about conductors and insulators. Conductors are materials that easily allow transfer of electrons, okay? And you could think about conductors. Most of them you probably would think about a metal is an excellent conductor. And insulators are just the opposite. They do not allow charges to easily flow through them. Okay, so insulators that are really good are things like rubber, plastic, glass. They are good insulating materials, where metals are great conductors. Okay, and we need to think about this because we use a device in electrostatics called the electroscope. And this is a device that detects the movement of charges. So if you bring a charged object near this device, you can see what it's made up of. It says metal foil here, but the ones we have, they actually have a little round metal knob connected to a stem. And there's a stem inside here, and then there's foil leaves down at the bottom. Okay, and if you bring a charged object near the top of this electroscope, like a charged rod of some sort, the movement of the charges within the electroscope causes the leaves to deflect. And that's how you know there's a charged object near the electroscope. So when we look at the electroscope, the only charges that are free to move in solids are electrons. So anytime we look at charged bodies, we're thinking about the movement of electrons or the negative charges. All right. And one thing we're going to keep in mind is that protons never move. Why do protons never move? Because they're inside the nucleus. Okay? When we talk about protons, they're not transferring from object to object because they're stuck inside the nucleus. The electrons are on the outside. And when we talk about charges moving around the electroscope, we're always talking about the movement of electrons only. Right? And this is a good multiple choice strategy if you think about it. You can always cross out the questions that ask you anything about protons moving. Protons never transfer. Protons never move. Okay? Now let's flip to the next page. All right, a couple definitions that we have to get down are, they seem kind of strange, but if we were doing the lab in class, you would see what I was talking about. So if we have a rubber rod and we rub the rubber rod with fur, it develops a negative charge. Okay, why is that? This means the rod gained electrons and the fur lost electrons. So if you picture that, we have the fur, we have the rod. So the rod becomes negative. That's because the electrons moved from the fur to the rod. Okay? We're never going to say something gains protons because they never do. It's always the movement of electrons. Okay, so you have to think about this definition as a rubber rod and fur. That's always giving the rod a negative charge. Now, alternatively, we have a positive one too. A glass rod rubbed with silk, okay, develops a positive charge. This means the glass rod lost electrons and the silk gained electrons. So once again, something became positive, not because it gained more protons, but because the electrons went from the rod to the silk. And I know this feels like it doesn't make sense, and why do we have to know this? But this is just one of the definitions that we have to learn and realize. So fur is always negative, glass is always positive. All right, something you may have heard of is something called grounding. Grounding an object involves touching the object and allowing charges to flow off of the object. This neutralizes the charge of the object. And this is represented as this drawing over here. This is a ground wire. You have ground wires in your house. They're the third prong on a 3-prong plug. And they allow charges to flow off devices and literally into the ground. So if you have like an expensive piece of equipment, it usually has a ground wire on it because you don't want to short out your expensive equipment. So it allows a path for extra charges to flow. So if you look at those plugs, that round one on the bottom, that's the ground wire. And in your house or wherever you live, that is connected directly to the ground, like the circuitry through your house. And then there's usually a wire that goes directly into the ground so charges can release. Okay, but we could ground an object just by touching it. So remember when I talked about dragging your feet across the carpet and you touch the doorknob? When you touch the doorknob, you're grounding yourself and allowing charges to flow off of you, and that's why you get a shock. All right, so now we're going to talk about charging the electroscope. I'm hoping we could find a video and I could put it up on Canvas for you guys so you could see what an electroscope is, how to charge an electroscope, and we could just talk about it in theory now, and then hopefully you could see it in action in a little bit. Okay, so we have 2 different types of charging. The first type of charging is charging by conduction. Okay, conduction starts with C-O-N. C-O-N. And so does the word contact. Okay, conduction, contact, conduction. So when you charge something by contact, the two objects are going to touch. When you touch objects, that causes a transfer of electrons. All right, not protons, just electrons. Okay, so anytime we're dealing with an electroscope, we're starting with a neutral electroscope. So what I'm drawing here is positive and negative charges across the electroscope. I'm not quite sure why this is so cramped, but I might actually add another page here so we can have a clear page to kind of draw and deal with what we want to do. All right, so we're going to be drawing all of the electroscope pictures. So I always start with a neutral electroscope. A neutral electroscope would have the same number of positive and negative charges spread out throughout the electroscope. Okay, and then since we're charging by contact, okay, the rod would touch the electroscope. Okay, let's say we had a negatively charged rod. And if you remember, a negatively charged rod would be a rubber rod rubbed with fur. Now this contact, this connection between the two objects, causes a bridge where charges can flow. So objects that have a lot of negative charge, they're going to repel all of those negative charge that are free to move to a more neutral object. So this is what happens during conduction. Any available electrons that can move will move onto the more neutral object. So the electroscope was neutral. So all of these extra electrons that are free to move are going to gather on this device. And on these leaves, remember these leaves, they're like light aluminum foil. And so if you have a lot of negatives next to negatives on here, what's going to happen is that the leaves on the bottom, they're going to repel and they're going to push apart because we have like charges next to like charges, and these are so light that they actually push apart. Okay, and after you remove the rod from the electroscope, after you get that contact, removed here, you still have all of those negatives, those extra negatives on the electroscope, and the leaves remain repelled. Okay, so charging by contact. So we're going to have contact. That's conduction. This causes electrons to transfer. And if you look at the charge on the rod and the overall charge after the charging was completed, you'll notice whatever the rod was is going to be the overall charge on the electroscope after. So this has a negative charge. After the charging is completed, the rod had a negative charge. So with conduction, the two objects end up as the same charge. Okay? There's a lot to digest here, but like I said, I'm going to try to find you a video where they show this happening, but realize and take in what the notes say. So when the charging by conduction touches the electroscope, the rod and the electroscope have the same charge. Okay. Now, induction is another type of charging that we deal with. So the last type of charging we're going to look at is called induction. Induction is when you bring a charged rod near to but not touching the sphere. So I'm going to do another picture for this as well. So we're doing induction. Okay, just got to turn my notifications off. All right, induction. This is near to. not touching. So we would start off with a neutral electroscope, just like in the last picture where we have the same number of positive and negative charges evenly distributed throughout the electroscope. Okay, and let's just do another negative rod. Okay, and you have to think about what's happening internally to the electroscope. So the negatives repel from negatives. So any negatives that are free to move in here are going to repel away from this highly charged negative object. Okay, and they're going to go down to the leaves. So on the leaves, we no longer have a balanced charge. We have all of those excess electrons that repel down from the rest of the electroscope. And now we have negatives next to negatives, and the leaves are going to repel. Okay? Once the rod is removed, that giant source of negative charge, the electrons within the electroscope, they go back to their original positions. They no longer have that excess negative charge repelling them away, so they return to where they were. Okay? And if you look at the overall charge distribution, the rod was negative, the leaves turn out negative during charging by induction, and the knob on the electroscope came out positive. So, we could kind of sum this up as that the rod and the leaves will have the same charge, but the rod and the knob on the top will have opposite charges. Okay? And I know this is kind of confusing, but it applies in every case. And we don't just have to use a negative rod. We could also have a positive rod, and the same thing would happen, but in the other direction. Like if we did, let's say, if we had a neutral electroscope to start with, where we had the leaves hanging down, nothing charged, and then we bring a positive rod near to but not touching the top of the electroscope. Instead of the electrons being repelled down, they would be attracted to this highly positive source on top. So remember, the positives can't move, they're locked within the nucleus. Okay? But the electrons can move, so any available electrons would be attracted over to the top. And now we still have opposite charges on the leaf, not opposite charges, sorry, like charges on the leaves, so they would repel, they would push apart, okay? When the source of positive charges was removed, it would go back to neutral. So this is also induction. This just happens to be with a positive charging object rather than a negative charging object. Okay, so, take it in, think about what I said. The electroscope does come up in some multiple choice questions, and we'll try those next. Let's just get these notes down on this page. When charging by induction, the rod is brought near to the electroscope. The charge on the rod is opposite to the charge on the electroscope sphere. So we're talking about the top, that knob piece, okay? But look what it says again here on the bottom. Very important piece of information. When charging objects, only electrons move. Okay, we're never talking about the positives moving up and down. We're only ever talking about the electrons moving up and down. And that's when I went over in the two pictures. Only net movement of electrons, never protons. Okay? All right, so I think to kind of cap this off, we'll do this one little bit of notes, and then we will do these 4 electroscope questions down here at the bottom. So up at the top, we have a neutral object. Okay, so this is a neutral pith ball. So a pith ball is a very light piece of styrofoam that's dipped in graphite paint. And when you bring a charged object near it, you could attract it or repel it, depending on the charge of everything. But here we have a neutral pith ball. if we have a negatively charged rod over here, okay, remember, positives can't move, they stay where they are. But think about what would happen to the negatives inside here. If we have this big negative charge near a neutral object, those negatives would repel away. And then what would happen is we'd have this split of charge. This is called a polarized charge. The polarized charge means that we have an uneven charge distribution. And the positives are on one side, the negatives are on another side. You can probably think about a polarized charge when you think about maybe putting a balloon and sticking it to a wall. If you charge up a balloon on your hair, you're giving it a negative charge. And then you bring it to a neutral wall. Well, inside the wall, we have positive and negative charges. But when you bring that negative balloon near to it, those negatives are going to repel away. The positive charges are going to stay where they are. And then this little balloon is going to stick to the wall because you have positives attracting the negatives and the negatives within the wall repel away. So that's actually like a polarized charge as well. You have that split in charge. Okay? All right, let's try a couple of these multiple choice questions down here. So number 1 says, when a neutral metal sphere is charged by contact. Okay, contact meant what again? Think about it. With a positively charged glass rod, what happens to the sphere? Okay, so we have a sphere, it's neutral. We have a positively charged rod charging by contact, okay? Remember, that's conduction. Okay, so what happens in here? And I told you a little trick about looking at the answers. Does the sphere lose electrons, gain electrons, loses protons, or gains protons? And immediately cross out any answers that have protons. Those are always wrong. Protons never move. Protons never move. So if you ever get a question asking you about protons, just cross out the answers. All right, so it's got to be either loses electrons or gain electrons. So looking at this, if this has a neutral sphere, it has the same amount of positives and negatives. The rod is overall positive. So the rod is going to take away any electrons that it could possibly get. So the sphere overall loses electrons because it gives up those electrons to the sphere. All right, let's try number 2. You try it first. Read the question. Pause the video if you have to. Okay. I'm going to go over it, though, right away, so we have no dead time. But number 2 says, which diagram best illustrates a neutral electroscope being charged by conduction? Right, so conduction is contact again. So already I could get rid of 1 and 2 because there's no contact between the two objects. All right, and remember the rule about conduction. Conduction, you have to have the same charge on the rod and the electroscope. All right, so looking at number 3, we have a negative rod, positive leaves. That's not the same charge, so we got to get rid of that. Number 4, we have this rod is positive, the leaves are positive, so that has to be conduction. All right, so try number 3, and pause the video if you have to. Number 3 says, which diagram shows an electroscope that has been charged by induction using a positive charging object? So induction is when we bring the rod near to, but not touching the electroscope. So some of these pictures are kind of cryptic, but we're going to think about what happens during induction. Okay, so if I have a positive rod near to this, that would cause the electrons in the electroscope to move up to the top, leaving positive and positive on the bottom. Okay, so which one is showing positives on the bottom, negatives on the top? Well, definitely not 3, definitely not 1, definitely not 2. Okay, It's actually 4 because these are not on the leaves. They're showing us like the mid section of the electroscope. So you kind of have to roll with the punches on these because they are terrible pictures. Right. In number 4, it says the diagram below shows a neutral pith ball suspended by a string, and a positively charged rod approaches the pith ball. So these are positives. Okay. The ball will first move toward. Well, remember, the pith ball is neutral, so it has negatives and positives in here. When the rod is brought near to that pith ball, the negatives are going to go on one side, the positives stay where they are because they can't move. But the ball will move towards the rod initially. So that direction would be C because it would be pulled towards the rod because of electrostatic attraction. So the answer is C. Okay? So I hope you enjoyed the electroscope. It's kind of difficult at times, but the more you look at it and the more you see questions, it kind of gets better. All right? Well, have a